Let's continue our Sudoku adventure with Intersection by Strosahl. So the grid looks quite busy. I can see why it's called Intersection. All right, so let's go over the rules. We've got normal 6x6 Sudoku rules, which means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have arrows in the grid. They're attached to circles. Whatever digits go on the arrows, let's say this is 2 and 4, you add those up, and that is the sum of them goes in the circle. So 2, 4, 6 is a possibility, or 1, 3, 4, or 2, 3, 5, or 3, 2, 5, right? For the arrows that are 1 in length, that just means it's the same digit, right? Like 2 and 2. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, so we've got a trick. I mean, I see there's a ton of circles here, but I actually want to start here because there's a neat trick with arrows, which is we know that the sum of these goes here and the sum of these goes here. So the sum of these 4 digits is the same as the sum of these 2 digits. Now, what do these 4 digits add to at minimum? Well, we can't repeat anything. So at minimum, we're putting 1, 2, 3, 4 there. That adds to 10. At least, right? So these 4 cells add to at least 10. Now these 2 cells then add to at least 10. So what is the smallest digit I can put in here? Well, I can't put a 1 because the other would have to be 9. 2 would need 8, 3 would need 7. So these are from 4, 5, 6. Can we repeat that trick anywhere? Yes, down here we have the exact same trick. So these are also from 4, 5, 6. Okay. I wanted to think about what cell is missing, but I don't know. Okay, we can think about these add to at most 12. So if these add to at most 12, that means these add to at most 12. So we can do a little bit of math here. So let's say they add to their maximum of 12. What we're trying to do is we're trying to minimize this cell. So if we try to minimize this cell, that means that this needs to be maximized. The rest of the cells need to be maximized, right? So these 4 cells adding to 12, if you think about it, the entire box adds to 21 because it has 1 through 6 in it. So we do 21 minus 12, that's 9. That means these 2 cells add to at least 9. In fact, they add to 9, 10, or 11 because the only options here are 10, 11, and 12. So 9, 10, or 11 is the sum of these cells, which means they sum to at least 9. This is at most 6, so this has to be at least a 3, and same thing here. Okay. Good stuff so far. I want to think about this traffic jam in here. I want to think about 1s and 2s, but we have to be careful because this cell here and this cell here could be any digit. So, but this cell, for example, and this cell, and this cell. So none of these cells can be 1 or 2. Because you can't add to 1 or 2 in 2 different digits. So 1 and 2 are squeezed into these. Now, if the 1, 2 ended up here, this would be 3. That seems okay. If the 1 or 2 were here, it would repeat here. Would end up here. That seems okay. So I'm not sure if I can make any conclusions about that yet. If this wasn't a 1, 2, 3 triple, that means I need a 3 in one of these circles, which would put a 1, 2 on its arrow. That seems okay as well. All right, so maybe not. Maybe not the 1, 2 in these boxes. I thought maybe. We can do the same trick here, because these 4 add to at least 10, right? So we're going to have the same thing going on here. Oh, and I think that's going to mean this can't be 1 or 2. All right, so let's think this through. So these add to at least 10, which means these add to at least 10, which means this is also from 4, 5, 6. And this is also from 4, 5, 6. And so now these add to at least 10. In fact, these add to 10, 11, or 12. In fact, actually, they can't even add to 12. These add to 10 or 11. So these maximize at 11. So the minimum sum of these 2 is 10. So that means that these are from 4, 5, 6. This is a 4, 5, 6 as well. Now we have this 4, 5, 6 triple. And I think we can do the same exact thing down here, right? So these add to 10 or 11, which means these have to be from 4, 5, 6 as well. So these are our 1, 2, 3 triples. And it's clear that 3 is the biggest number. It goes in the circle. We get a 1, 2 pairs here. This ends up being a 3 for the column. We deet in the corner. Nice. This is a 1 or a 2, just for the column. Okay. We just got a bunch of stuff. What did we learn? We learned that one of these is a 3, because this 3 goes up here. Okay, one thing I can say is that these are not 6, because we can't put a 6 on an arrow, because we can't add it to anything to make something bigger, right? So 6 ends up in one of these two, which means this is not a 6, which means that's not a 6, which means 6 is one of these two, which means in this column, where does 6 go? Well, it can't go on this arrow for the reasons we just discussed, so it goes here. That means this is not a 6. Okay. Interesting. So we need 1 and 2 in this row, and they can't both go over here, because then that would add to 3, which it can't. So the other 1, 2 goes here. This can't actually add to 4, though, because we can't do 1, 3, because there's already 3 in the row. So this has to add to 5. And it's going to use the other 1, 2. Oh, but it can't be 2, 3. So this is 1, 4, and that makes that a 2. Okay. Did that? I probably did that in the most roundabout way possible, but it was fun. All right, 1, 4 pair does put a 6 here and a 4 here. That makes that a 4. None of these are 4s. That's not a 4 either. All right, we end up with this 1, 4 down here. This is 2 and 1. This is a 2. That's 1 and 2. All right, this is resolving. What do we have going on here? These indeed add to 10 or 11. We know there's a... Oh, we can place the 2 because of all these 2s looking in. So there's a 2 here. So this adds to 5 or 6, which means this is 3 or 4. Oh, and it can't be a 4. Nice, there's a 4 in the row. So that's a 3, that's 5, that's 6, that's... Oops, I didn't mean to do that. That's 6. This is still a 4, 5 pair, though. So this definitely has the 1 on it, which can only go there. And then this can't be a 6, right? So the 6 ends up here. Actually, I probably could have seen that none of these were 6 a while ago. I'm taking a roundabout route to the solve, but it's fun. This is 1 plus 5. So these can't add to 4 because the 3's gone. So they add to 5. That's a 1, 4 pair. These are now both 4. That's a 5. That's 1 and 4. Over here, we've got a 3, 6. And we know the order, so that's 6. Places the 3 here. 3 plus 2 is 5. This is 1 plus 5, which goes like that, and we're done. Nice. Cool puzzle, Scott. I appreciated that. Yeah, it was neat how we had this trick over and over again of these having to add to at least 10. And in this case, these actually were more restricted because they couldn't add to 12. In fact, did they all end up adding to 10? 1, 2, 3, 4. Nope, they didn't. These added to 11. Okay, yeah. So these added to 11, and these added to 10. Okay, cool. Yeah, neat puzzle. I think I could have noticed a few things earlier, like thinking about how 6 couldn't go on most of these arrows. I thought about 1s and 2s not in circles, but I didn't think about 6s not on arrow cells. And had I think I would have discovered more about the puzzle earlier. But cool. I enjoyed my solve path regardless. Hope you enjoyed this as well. If you did, then why not leave a like, subscribe, and a kind comment below.